Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Cage Growing by Vizumation. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Digits in a cage must sum to the small clue in that cage. Digits cannot repeat in a cage. Okay. Okay, because the thing is, I was wondering how that was going to happen with this being 27. But here's the part that it says. Cages only grow north and west, which is up and left. Cages do not overlap. Size, shape, and sizes must be determined by solver. Digits in a gray circle must be odd. So basically, digits can only cages, can only grow up and left, or north and west, as he says. So that means like an example of a cage could be something like along the lines of this, right? And we have to determine what the cage is. And all the digits in the cage sum to what's in that number, right? So these four, if this was the cage, these four would have to add up to 12. And an example here could be something along the lines of 3, 6, not 3, 9, 3, 6, 2, and 1, right? And this is normal cages. So basically, in addition to, we don't know where the cages go. We also know that you cannot have a cage grow south or down, and it can't go right. So cages can only grow left or up. And it could go like this, then up, right? So that could be possible. So it could be something like this, right? We just don't know. But it can never grow this way. And this is typical killer cage Sudoku, where digits cannot repeat in cages, and they must sum to the clue in that cage. Also, cages do not overlap. So shapes and sizes must be determined by solver, so this could never be part of this cage, right? This could never be part of this cage or any other cage. It's part of its own cage, right? And then we have digits in a gray circle must be odd. So for example, this could be 1, 3, or 5, actually. And we have digits separated by a black dot are in a 1 to 2 ratio. So for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's look for cages that cannot grow left or right. And that's one of them here. Sorry, left or up, top. Left or up. And this one cannot grow left or up. So this has to be 3. This one can grow left or up, so this is part of this cage. This is its own separate cage, so we're going to have that. This one has to go up, so this one could be a single digit, or it's 8. We're not sure which. This can only go up, and it has to have at least 5. So we're going to make that 5 at least. Let's mark the cage's boundaries. So this is 1. Obviously, this is 1. This is 1. This is 1. This is 1. We know that's 1. This we know has a boundary, and this one has a boundary. This 5 is in a 1 to 2 ratio with something. So it can never be. So this actually cannot be 5, because if it's 5, this is in a 1 to 2 ratio with something, and 5 can never be in a 1 to 2 ratio with anything. And it can't be 3, so this actually must be 1. Well, we know it goes either left or right. This 1 has to be in a 1 to 2 ratio with another digit, so it's 2. But if you have 1 and 2, the problem is that you would have to have another 2 or another 1 to fill that cage. But we can't have repeats. So it can't go this way. This cell then must just go up, and it must be a 4. Because we have 1 and 4. Those are the only possibilities for a cage. This also has to go up. So we'll mark that as, I don't know, green. Oh, so since this goes up, this has to be, this is all where it can go, right? So this has to be 5 and 6. Actually, no, that's not true. This could be 4 and 7 here, or this is 5 and 6, or it could be 2 and 3 here, which would make this 8 and 9. That's possible. This we're not sure of. This can only go up if it's not a single digit, but it could still be a single digit here. This is interesting. This has to be 1, 2, 3, 4, 5, 6, 7, 8 at least, at most. Okay, so this one we know has to be at least part of this. So these are part of it, and this is part of it. It has to be at least 7, right? And it could be 1, 2, 3, 4, 5, 6, 7 here, or it could continue on here. We don't know. So this one cannot go any other way here. This is 32. 1, 2, 3. It has to be at least 5. So it could be 5 here. That's fine. This is 45. That's interesting. So then this part has to go at least to here. Actually, 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, it could extend to here. So we know this has to extend here. Because it's 1, 2, 3, 4, 5, 6, 7, 8 at least, and this would be at least 9. So one of these two has to be. So this must extend that way. This cannot be part of this. This can't be 5 either, right? So we'll mark this as yellow. This can't be 5, because if this is 5, this is in a 1 to 2 ratio. So this must go up. And it cannot be 3 and 2 here. So it has to specifically be 1 and 4. So this is separate. This has to go up. So it goes up by itself. This has to be 10, because that's the only thing that can work there. Because it has to be 2 here. This has to go up, obviously. But we don't know where it goes up to. This, then, because this goes up, this has to also go up. So let's mark that as red. It has to be at least 4. So it could be 4 that way. This can only go sideways, and it has to go 4. So we'll go 4 that way. This has to be at least 2. So then this has to go that way at least. And it could be 3 at most, but that's it. So this is a border. This obviously has to be a border. This is a border. This is a border. This is a border. This could go left or up, so that's fine there. This has to go up, and it's at least 3. So therefore, we're going to mark that as green. This 12 can only go that way. So it has to go that way then. So this is a border. This is a border. We don't know actually that one. So let's go there. This is a border. This is a border. This is a border. This can only go this way. So we're going to mark that yellow. This is red. We know it has to go somewhere. Hold up. So this is 12. So this cannot be just 3 digits, right? If this is 12, this can only be 3, 9, 4, 8, or 5, 7. But if this is only 3 digits, this would be 7, 8, or 9, which eliminates all possibilities for this cage. So this one has to go up. So we know this is a 4 that goes up. This is either 3, not 6. This is 3, 9, 4, 8, or 5, 7. This must contain 9 digits, so it's 1, 2, 3, 4, 5, 6, 7. It could be 8 here, but it definitely has to go here. So this is 8 here, because it needs at least 9. So it has to be there and here, or here and here. Well, that means this one has to go this way, which means it has to go up here. So that's 5, which it needs, because only 4 unique digits can add up to 30. So this has to go up. This is continue drawing around the outside border. The red must go up, so this has to be red, at least. And it could go left here, but we don't know. So this is either here or here. This one could be here. This one has to go up. So we'll mark that as blue, and it has to be at least 3, so therefore it goes that way. Therefore, this one must go this way, and we don't know if it goes any further. So this is a boundary, this is a boundary, this is a boundary. That means this one has to go up. So we'll make that, uh, we'll make that green. Oh, and it has to be 3, so therefore it goes the full amount. So this is a 3. Okay, so this is 10. This has to be 20, so that's 30. So this cannot be 8 and 9. If it's this, well, actually, it could be. This is 3. Ugh. 3, 8, and 9. Well, obviously that can't be 3. It could be 4, 7, 9, or 5, 6, 9, or it's 5, 7, 8. This is 1 and 9, 2, 8, 3, 7, 4, 4, 6. That's a lot of possibilities. We don't know about this. This could be an 8 by itself. This one actually has to go that way, because it can't go up anymore. So this one, actually, we know has to go this way, which blocks this. So this has to be essentially another 4, 5, 6, 8, and 9, and this is 2, 3, 5, 6, 7, because this can't be 2 or 3, and this can't be 4 here. So this can't be 4 here. So we have that. This one, we're not sure. It could go up, it could stay there. This one has to go up at least, because it has to be at least 4. So this is at least 3 here, and it can't go any further this way. This 5, well, we don't know. This is either 5 or 2, 3 here. We're not sure which. Hmm. This isn't a 1 to 2 ratio with something, so it must be 2 or 8, but we're not sure which. Because 1 could be in 1 to 2 ratio with 2, 4 can be with 2 or 8. Now, this is interesting. Okay, so first of all, what is the minimum here? It has to be 3, 4, and 5, which is 12. But the minimum here, then, for these cages has to be 36. So 36 plus 12 is 48, and that's not possible. So therefore, either this extends all the way out, or this extends all the way out. But we know then that neither of these can be essentially just in this area, right? Because if it were, this would be too small, or sorry, this sum would be too big, right? Because this would be at minimum 12, and these would have to be 36. So that's 48 for those cells, assuming it doesn't include that one. So this is either yellow or blue. We're not sure which. This then has to be yellow or blue. Therefore, this one has to extend that way. So it's 1, 2, 3, 4, 5, 6. It could be just 6. Oh, actually, this was actually an incorrect assumption. We could only extend to here because it could have been 6 that way. But now we know that this specifically has to be a different cage, so it cannot be anywhere else here. So this could actually be 6 here, right? Because you have 3 digits potentially adding up to 10, which is possible. Actually, this could even be 5, but this since it's part of here, this extends it to here. So actually, neither of these were... Well, this one was not guaranteed. But this one, since this was guaranteed, it could not be 5, 6, 7, 8, 9, adding up to 35. So this would have to be at least 6. So now we know that... So that assumption was actually incorrect, but we got to there eventually. So either this or this is part of this cage, but we don't know which one. This one is blocked here. So this is either 6 or 7. This is 5 or 6. We already have this done. This cannot be 1 or 4 here. So the remaining digits are 2, 3. Can't be 3 because of this 3. Because if we have a 1, 4 pair here. So it could be 2, 5, 6, 7, 8, 9 here. And this is 2, 5, 6, 7, 8, 9. This can't be 9, obviously. This can't be 7, because if it's 7, it has to be with a 1, and that's not possible. This can't be 5 then, either. So this is specifically 2, 6, or 8 here. So, interestingly enough, either this is 8, which forces that to be 2, or this is a 2, 6 pair, which forces that to be 8. Either way, 2 and 8 cannot be in the rest of the column. Right, so either this is 8, which forces that to be 2, which means 2 and 8 can't be in the column, or this is 2, 6 with this, which means this is 8, and then 2 and 8 can't be in the rest of the column aside from this. So this can never be 8, because 8 is either one of these two, but this could be 2 or 6, or it could be 5, 7, 9, but this can't be 2 or 8, and these can't be 2 or 8. Interesting. So this is at minimum a 3 here, right? Because we know this is at minimum 3, 4, and 5. Hmm. What's included here? This is 10. This is 20. So that's 30 here. This is either 1, 3, or 4, right? Because it either goes up to, which would make this 1, 3, or it stays here, which is a 4. The rest of this is 4 through 9. This is 4 through 9. This, we don't know. We don't have any information about. This is at least, well, it has to be 3 through 9 without a 4, because this, same here. This is 3 through 9 without a 4. This can never have a 9 in it, because if it's 9, it would have to have a 2 with it, and that's not possible to add up to 11. So this is 1, 3, 4, 5, 6, 7, 8, which is fine. What else do we know? If this is 7 and 9, that's interesting. That forces this to be 5 and 6, which would force this to be 1 and 2 here. Right? Because there's no other place for 1 and 2. So then this would be 1, 2 plus 5, 6. So that would be 3, 5, and 6 added together, which would be 14, which would require this to be a 6, but then we already have this being 5 and 6. So this cannot be the 7, 9. So this one must be yellow. And this one actually has to be 20 here. Therefore, 1 and 2 cannot be here, because 1 and 2 can never add up with two other digits to add up to 20. So, because, right, 2 would have to be 9 and 9, which is not possible because you have a repeat. So this is, this could be 4 with 7 and 9. That's possible. It could be 5, 6, or 9 with the 5, 6, or 9. Or it could be 8 with the 5 and 7. So 1 and 2 have to be in this set. So that's 3, which means we have another digit. We have another 2 digits, which must add up to 16 minus 3, which is 13. And that's 4 and 9. So this could be 1, 2, 4, and 9. 1, 2, 5, 8. 1, 2, 6, 7. And those are the only choices. Okay. So 1 and 2 have to both be here. What does that add up to then? This is at minimum 35 plus 32 plus 5. So it's 40, 72, and then this is plus another 5, which is 77. But we don't know if this is 4 or if this is 2 or if this is 3 digits here. So that's not much information. Actually, that's a good question. What do all of these cages add up to? because we do have extras here. So this is 45. So it's really adding up the other ones. This is 32, 11, 32, 11, 5, 5. So this is 10. So this is 43 here. This would be 53. We have 10, 12, and 24. So that's 46. Okay, hold on. I need to pause because I need to go to the bathroom right now. Let me pause. Okay, and we're back. Let's continue. Right, so these three add up to 46, right? 10 plus 12 is 22, plus 24 is 46. This 5, 5, 11, and 32 adds up to this is 10, 11, plus 32. Again, this is 43, 53. So 53 plus 46 is 99. And plus the 45 would be 9 more than what 3 boxes would add up to, or 3 rows. That's interesting. Hmm. Is it? It's. Let me just double check. I think it is 9, right? 11. This is 43. This is 10. So therefore, it's minus 2, considering, and then plus 10 would be 8 plus 8. And this is 1 more than 45. So yeah, these two at minimum add up to 9. We know that for certain. Okay. What does that mean though? Um, oh. Well, no, never mind. I was thinking something else. Never mind. This is 5. Okay, this is at minimum 6. So this could be 1, 2, 3 at minimum. These added together is 46. Right? So that's 46 here, plus another 6 at minimum, which would be... That's interesting, because then that would be 2, 3... Okay. That's problematic. So if this were trying to be 1, 2, and 3, 1 would obviously be here in this box. But where would the 2 and 3 be? Couldn't be here. Couldn't be in any of the blue. It couldn't be here. And therefore, it would have to be these 2 cells specifically. But we know this can only grow, the cage can only grow left or up. And it can't go up anymore. If we try to go left, the problem is that would require 2, 3, 2, 3 pair, which would eliminate that possibility. So this can never be just 1, 2, and 3. It could be 1, 2, and 4, which would be 7. So 7, that for... This could be 7, and this could be 46, which would mean this would have to be at least 8 over. Yeah, I guess it's actually trying to understand what this could be, right? If we had, so 11, 32, 5, and 5, that's 8 over what the normal 45 would be, right? Because 11 plus 32 11 plus 32 is 43, plus 10 is um, plus 10 is actually oh, actually that's interesting. This digit sees all of these digits. And if there's a digit here, it sees that. So this digit must be one of these two digits here. Right? Because it sees all of these. So that's 6 or 7. And then it must be the last it must be in the blue cage somewhere, but it can't be any of these. And if this is a continuation of the blue, it cannot be that one either. So it would have to be here or this one, depending if the blue goes up here. So either way you cut it, this A has to be one of these two cells. So we know then that the full amount of 32 has to be essentially here with one of these two cells. So because of that, we know assuming this was not yellow or red, this would be 11, and these four with another digit would be 32. But then you would have two digits adding up to 45 minus 11 minus 32, which would be 2, which is not allowed. So this specifically has to be yellow or red. And we know the A is here. The 2 must be here too. So this is guaranteed to be 2. And the reasoning for all that is specifically, again, we know this digit has to be in the blue cage here. And it cannot be any of these because it sees all of those. So it must be in box 7 then. Either here, if that's the extent of it, or if the blue cage extends further, then it's here. Therefore, the full amount of 32 is in this cage. So if this was neither yellow or red, the problem is we'd have an extra digit here, right, no matter what, which must be something. And this cannot be essentially... and if we had an extra digit, the yellow parts and the red parts must add up to 43. But then if we had an extra digit here and an extra digit here, that can never add up to 2, which is the remaining digits left, because they have to be different digits. Therefore, this has to be either a yellow or a red. We're not sure which, to contain that. And the extra digit has to be the one that's remaining here, which is a 2. Now, the 2 doesn't have to be part of the blue, so this doesn't actually have to be 2 here. That's actually very clever. I like that. So that means this is all filled. We don't know about this. This could actually all be filled too, right? Because the 5 could continue here and be part of that. And then this could be the blue, right? And then this, interestingly enough, the 2 has to be here, which means the 2 has to be one of these 3. Oops. We don't know what this is, though. Hmm. And again, this could be 9. Um, because we know this is 8 at most, or 8 at least here. And this is 1 extra. So this could be 1, 2, and 4 here. And in fact, we know at least one of 1 or 4. Well, it could be here. There's no guarantee. This is at least 46, though, here. Oh, interesting. We have full amounts at least of these. Well, not completely. Just these, actually. Hmm. What does that add up to? This is 46. This is 46. Um, huh. 46 plus 4 is 50. 26 and 17 adds up to 43. 43 plus 20 is 63. So we have 63 and we have 50. 63 and 50 adds up to 113. This is at least 10 because you have 4 digits here. So 113 plus 10 is what is it? 123. This we know is at least 7. Hmm. Hmm. Actually, should we add up all the cages? Maybe that's better. I'm gonna add a calculator because this is too much to try to do everything. So here's a calculator. You can't see that portion. You can't actually see. Can we shrink the calculator? We can. Okay, let's shrink it then. So you can see the value. Okay. What are all the cages added together? 27 plus 12 plus 14 plus 8 plus 5 plus 11 plus 11 plus 3 plus 26 plus 20 plus 17 plus 32 plus 35 plus 16 plus 20 plus 4 plus 5 plus 10 plus 11 plus 5 plus 12 plus 24 plus 32 plus 45. Aha! Which is 405. And if you divide that by 45, that's 9. So we know all the cages must fill the entire grid from that. That's what I was suspecting, but I didn't. Actually, I didn't suspect that at all until I just thought about it. But basically, that's what I naturally thought after a while. Okay, let me pause. I need to go to the bathroom again. Actually, I need to do something. It's we'll be right back. And I'm back. Sorry about that. Yeah, pausing when we had got to such an exciting conclusion. Yeah, I don't know. Sorry, I had things I had to do. But basically, yeah, we added up all the cage values, and it comes up to 405, which is 45 times 9. So all the cages must fill the entire grid. We didn't actually know that before. I didn't actually think about that, but it actually makes a lot of sense. Therefore, we know this can only extend to 1. And the only one that's not available then is here, right? Because otherwise it's not going to be able to essentially extend anywhere else. Sorry, no other cage can extend into this space. So this is the only space that blue can be then, which means this cannot be a 2. This has to be the A. And this has to be a 2. So this is 2. This is an A, whatever A is. And this must extend into this space because there's no other cage that can do that anymore. Because this has 9 now. This cannot go right or down. So therefore, this must be the extension here. Therefore, this is a pair. And this has to be a 3 then. To add up with 2. Right? And it has to be 2 because, again, as we said, it has to be A because it sees all the other cells here. This must extend here because there's no other cage that can do that. This must extend here because, again, there's no other cage that can do this. This has to be a 1-3, 1-3 pair, which eliminates 1 and 3 from the rest of the box. This can't be 3. Therefore, this can't be 7 or 9 because this can't be 1 or 3. This can't be 2 or 3, which means this can't be 7 or 8. Let's see. One of these has to be filled. So this is either orange or red. And this is either pink or yellow. This has to, well, okay. So the orange can be 6. But the problem is, okay, so this can never go all the way to the end, right? Because it's only 27. So it has to be at minimum 7. Actually, I think it has to be 6. It can't be 7 because the minimum of 7 digits would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, which would be 28. So this is at minimum 6. So this can only go to blue here. This red can only extend to 4. So either of these could be red, but actually this one specifically has to be red. So either this and this one, if it's not red, has to extend. This 12 cage can only be 4 in size, right? Because if you have 5, that adds up to 15 at minimum. So it could go up here or it goes up here. But if it goes up here, this no longer has a cage that can add up to it. So it can only go up here if that's possible. So this one then has to be a blue. Therefore, this is at most here. This blue goes at most here, which means this has to be an orange because that's the only one that's possible. This is 1, 2, 3, 4, 5, 6, 7. And you can only have 7 digits adding up to 7. You can't have 8 digits because if you have 8 digits, that adds up to a minimum of 36. So this has to be orange, which makes this have to be green. So now we know these boundaries at least. This is a 1 or 3 here. This then we know adds up to exactly, so this has to be exactly 9, I believe, right? Because if it's not, so all of these add up to essentially 135 plus whatever this is. This again is 46. This is 45, so that's already 1 greater than 2 sets of 1 through 9. Then we have 5, 5, which is 10, plus 43, which again, so this has to add up to 9. So this cannot be 9. It can't be 6. Therefore, this must be 6 or 8 here. This is 2 or 4. It has to be with 5 or 7. Because we cannot have a 1, 8, 3, 6 pair. Because 1 and 3 are already in. We have a 1, 3, 1, 3 pair in the box. So, what does that mean? Not completely sure. This can't be 3, so therefore this can't be 8 here. Okay, what can these be? This could be 389, that's fine. It could be 479, and that's fine. It could be 569, and that's fine. It could be 578 also, actually, and that's fine. There's a lot of possibilities here. Anyways, this is either 4 digits adding up to 26, or it's 5 digits adding up to 26. We're not sure which. This can't be 2. So we know we need a 2 here. Oh, actually, we know this is 9 exactly. So this is 46 here. Actually, okay, yeah. Let's add up all of these cages, and therefore that would give us what's the remainder here. This has to be 5, 6, 7, 8, or 9. Because this sees 1, 3, and 4. This sees 2, so this is 5, 6, 7, 8, 9. So 2 has to be here, interestingly enough. What are these added together? So this is, again, 32 plus 11 plus 10, which is 53 then. 53 minus 45 is 8, so this must add up to 8. Because this is 45 plus 53, and then you subtract, that's 98, and you subtract out 90, which leaves that. So then this has to be 1, 3, and 4, because it cannot have a 2, because we know one of these is a 2, from that being a 2, and this not being a 2. So therefore, this has to be 1, 3, and 4, which means 1, 3, and 4 cannot be in the remaining set of in the box. So this cannot be 3, 9. It cannot be 4, 8. It has to be 5, 7 here. Well, the remaining digits are now 2, 9, and 1 out of 6 or 8. So that's 11. And then this adds up to 13, right? So that's because of this. Well, we have a 5, 7, 5, 7 pair in column 8, which eliminates 5 and 7 from the rest of the column. So this can't be 5 or 7. This can't be 5 or 7, and it can't be 1 or 3. So this has to be 2, 4, 6, 8, and 9. And this must be 1, 3, 2, 4, 6, 8, 9. Okay, this can't be 1 or 3 because of the 1, 3 pair in the column. So this must be 4, which means this can't be 4. This is 1, 3, and 4. This can't be 4 then. So the remaining digits in this column are 2, 5, 6, 7, 8, and 9. Well, we know 2 out of 5 and 7 are here. Right? Because 5 and 7 cannot be here because of the 5, 7 pair. This can't be 5 or 7. This has to contain 5 or 7. But if we tried to have... Well, actually, it could be. I was going to say we can't have 4 that add up to 5, 6, 7, but we could, actually. Can this ever be 2 with a 3 variables, a 3-cell cage here? If this is 2, the other 2 digits must add up. It could be 6, 9. So that's possible. This could be 3, 8, 9. 4, 7, 9 works. Okay, so this is either 3, 8, 9. It could be 4, 7, 9. It could be 5, 6, 9. But it cannot be 5, 7, 8. Because that would eliminate all possibilities for that cell. So this always contains a 9. So again, the possibilities are 3, 8, 9, 4, 7, 9, or 5, 6, 9. So this adds up to 32, which means the remaining 3 digits add up to 13. Huh. Okay. This can't be 2. Okay, well that's useful. So therefore this is a 2 here, which means these cannot be 2. So what's the minimum value these could be? 5, 6, 7, 8, right? So 5 and 8 adds up to 13. 6, 7 adds up to 13. Therefore, this must be the minimum. And it has to be 4 digits. So we know this can't be red. This has to be orange. And this has to be 5, 6, 7, 8, right? Because that's the minimum value, and that's the actual value of the cage possible. So therefore, it must match. 5 and 8 add up to 13. 6 and 7 add up to 13, which is 26. This then must be a 9. So this can't be 9. We know this adds up to 13 because this cage adds up to 24. Hmm. Can this ever be 1? 1 would have to be with 7 and 9 to add up to 17. And it's only that. So this can never be 1 because we can't have a 7 anymore in there. It could be 2, 6, 9. That's fine. Can it be 3? 3 could be 3, 5, 9, but that has a 5 in it, so that's not allowed. What about 3, 6, 8 works? No, it doesn't because this has to be 6 or 8. Oh, and in fact, this can't be 6 or 8 either because we have a 6, 8, 6, 8 pair in the row. This can't be 2. The remaining digits are, this can't be 3, 1, 4, 5, and 7. So this is 1, 4, 5, and 7. This can't be 1 or 4. Therefore, this must be 5 or 7. This still could be 3, 6, 8. Oh, cannot be 3, 6, 8. Right, so it cannot be 3, 5, 9 because we have a 5, 7, 5, 7 pair here. If we try to make it 3, 6, and 8, that would eliminate all possibilities for that cell. So this can never be 3 either. So it could be 2, 6, 9. What about 4? 4 would only require 6 and 8, which is not allowed. Actually, 4 and 6 and 8 adds up to 18, so that doesn't even work. It would have to be 4, 6, 7, or 4, 5, 9 if 4 was the lowest number. So 4 doesn't work either. Therefore, this has to be 2, 6, and 9 here, which means the remaining cells cannot be 2, 6, and 9. This can't be 6. Therefore, this is 8, which makes this a 5. This 5 means this has to add up to 9, so this must be 4 with it. This must be 6. We know there's a 2 in this box, but there's only one place for it now, which has to be here. So this is 2. This can't be 5, so this must be 7, which makes this a 5. This can't be 2. We have a 6, 9, 6, 9 pair here. So 2, 6, and 9 are no longer in the rest of the column. And this can't be 8 anymore, so this is 4 here. One of these must be 4, and the other one has to be 1 and 3. Well, no matter what this is, it can never be 2 digits, right? If you have 4 at maximum, you have to have a digit 10, which is not valid, to add up to 14. So this must be a 3-cell cage. So this is pink, which makes this yellow. So this is only 1, therefore this must be 8, which makes this a 2. This can't be 2 then. None of these can be 8. This is 4. This is also 5 and 6 here. So this cannot be 3. This cannot be 4, 7, 9, 5, 6, 9. It has to be 3, 8, 9. And this can't be 3, so this must be a 3 here. So this is 3, 8, and 9. Well, we now have an 8, 9, 8, 9 pair in box 6, which eliminates 8 and 9 from the rest of the box. So this can't be 8, 9. This has to be 6, which makes that 9. This can't be 5, 6, or 8 anymore, so this makes that 7. So these can't be 6 anymore, so therefore these can't be 5. This can't be 3 anymore, so this can't be 8. This can't be 6 or 7. This can't be 3, so this makes that 1, which makes that 3. None of these could be 3, so this is a 1, 4 pair here. This can't be 7 anymore. So this is a 5, 6, 8 triplet, which eliminates 5, 6, and 8 from the rest of the box. So this has to be then 2 and 7. Interesting. This can't be 5. This can't be 4 or 5. This is not 8. This is 2. So the rest of this can't be 2. The rest of this is 5 through 9. This can't be 5 or 7, so this can't be 5 or 7. The rest of this is 5 through 9. Interesting. This can't be 5 or 7. This has to be 5 through 9, but it can't be 5 or 7. So we have a 6, 8, and 9 triplet in row 8 and also in this cage. So the rest of the cage and the rest of the row cannot contain 6 or 8. So this can't be 6 or 8. This must be 1, 3, or 4. One of these is a 3. This can't be 6 or 8 or 9. So this must be a 5, 7. So we have a 5, 7, 5, 7 pair here in column 5, which eliminates 5 and 7 from the rest of the column. This can no longer be 5 and 6 to add up to 11, and this can't be 4, 7 to add up to 11. So this must be 2 and 9, which means this can't be 2 or 9. This can't be 9. This can't be 2. None of this can be 9. We have 3 digits adding up to 20 without a 9. It has to be 5, 7, and 8. So therefore, this is the 5, this is 7, and this is 8. Which means these can't be 5 or 7, so it's a 6, 9, 6, 9 pair. This can't be 5, that forces this to be 4, which makes that a 7. This can't be 4 or 9. This can't be 9, so this is 8, which makes that a 9. That 8 makes this a 5, which means this can't be 5 or 8. This can't be 4, 5, or 8. No 7 here, no 7 or 8. This is 1, 2, and 6. 1, 2, and 6. This can't be 2. This can't be 2. Therefore, this must be a 2. 1, 2, 6 adds up to 9. So the remaining digit has to be a 7 to add up to 16. So this must be 7. This can no longer be 7. The remaining digits here in row 5 have to be 1, 3, 4, and 6. But it can't be 1 because we already have a 1 there. This can't be 5. We have a 5, 7, 5. This can't be 8 or 9 because of the 8 or 9 in the column. So this is 6, which means this can't be 6. This can't be 6. This can't be 6, so this is a 1, which forces this to be 6. Remaining digits in column 5 have to be 3 and 4. And remaining digits in column 4 have to be 1 and 5. Okay. What does that mean? Remaining digits here are 1, 5, and 6. So this can't be 2. And this can't be 5. These can't be 5. This can't be 5. So we know out of these 4 digits, you have to have 6, 8, and 9 with it. That's 23. Which means if we try to make this size... Okay, so yeah, of these digits, of these 4 digits, 3 of them have to be 6, 8, and 9, which is 23. If we try to make this size 6 cage, the remaining 3 cells would have to add up to 6. Which could be 1, 3, and 5. That actually does work. Sorry, 9. It has to add to 9. Apologies. That could actually work. 1, 3, and 5. Or if it's only just 5 digits, it has to add up to 9 with 2 digits. And it cannot be 1, 8. It cannot be 3, 7, 3, 6. So it has to be specifically 4 and 5. Either way, then, this has to have a 5 here. Which means this can't be 5. So this is a 7, which makes that a 5. So this can't be 5. Therefore, this can't be 7. So we have a 5, 6, 8, 9 triplet here. So if this is not... If we try to make this 1, the problem is this doesn't add up 1, 3, and 5 to add up to the 9 because this can't be 5 or 3. So this can never be 1. This is specifically either 4 with 5, 6, 8, and 9, or this is 3 with 1 and 5, 6, 8, 9. Okay. What are the remaining digits then? Okay, so this is 3 digits adding up to 14. What can they be? If this is 1, it would have to be with either 2 or 7. 1 and 2 add up to 3, and therefore the last digit, or the last cell would have to be 11, which is not a digit, so that's not allowed. If we tried 1 and 7, I guess it could be 1, 7, 6. That works. What about 4? If you have 4, 2, and 9, that adds up to 15, which is already too big. You can't have 4, 2, 6 because that adds up to 12. 4, 7, 6 adds up to 17, so that's not allowed. So 4 is not allowed there. So this has to be 1, 7, and 6, which forces this to be 4, 2, and 9 here. This can't be 4, so this must be 3. Which makes this 4. This can't be 1 because of this one, so this is 5, which makes that a 1. What does this add up to now? This is 19, and it's only 5 digits. So this has to be the blue, and it has to be the 6th digit here, which must be 8 to add up to 27. So this is 8. This is 3 digits, so it must be 3 then, which makes this not 3 or 8. This can't be 8, so this makes that 9, which makes that 8, which makes that 9. This cannot be 3, 8, or 9, so this is 6. This can't be 6, 8, or 9, so this must be 5. Well, these can't be 5, and this can't be 9. This can't be 8. So where is the 8 in box 3? It has to be here. So this is 8. Remaining digits now are 2 and 9, and this cannot be 2, so this must be 2, and this must be 9. This can't be 2 anymore. Remaining digits here are 5, 6, and 7. And this can't be 5 here. There cannot be a 6 in the rest of the box, so this can't be 6. And it can't be in the rest of the cage, so this can't be 6. What does this add up to is the question. This is 32. Oh, this must add up to 13 here, and one of them is 6 or 8. So if we try to make this 1 and 3, that does not work. Right? Because the other one would have to be 9, but 9 can't be there. Oh, and the remaining digits here are 8 and 9, but this can't be 9. So this is 8, which theirs is 8, which forces this to be 9. This 1 means this has to be 3, which makes that a 1. This can't be 8, so this is 6, which makes that 8. And again, it cannot be 1, 3, so this has to be 4 as a solitary digit, which means 3 has to be here. And we have our final boxes filled. Or final cages, sorry. Therefore, this can't be 4. This is 1, which makes that a 4. This can't be 4 anymore. This can't be 4, so this is 3, which makes that 4. This 6 means... right, we already know this has to add up to 13, and therefore this is a 1, which makes that 7. This 1 means this has to be 6 and 7, which forces this to be 5, and that to be 1. That 6 means this can't be 6, so this is 5, and that must be a 6. And that's how you solve it. Pretty cool, actually. I wish I had actually, in the very beginning, added up the sum of all the cages. I just didn't think about that. Yeah, because I just didn't think it would actually fill all the cages, just given how, like, you know, few of the cages we had, right? Or few information-wise, the cages we had. Very cool, very cool. I like the logic of it, like the growing of the cages. Was very interesting. Anyways, I hope you enjoyed watching this solve, and I'll see you next time on Frank Puzzles. Take care.